neutral.
101.5.
And for our oppose, 53 minus, what did we get? 43. 3.5 squared over 43.5. And if we solve for this, did anyone get there yet?
You just square the top, right?
Just square the top.
So we're doing the chi-square for every...
We're to calculate the chi-square for this proportion, set of proportions based on our null hypothesis.
So we're doing it for each response and just adding them together.
Yes.
Okay.
For each response, we're calculating the expected value, and then we're adding observed minus expected squared over expected for each attitude. So support, neutral, and oppose. You get there?
I got 10.97 by
10.98. Yep.
So if it was to ask for the chi-square for just neutral, you would just do neutral. But since it didn't specify which response, you will do all of them and add them together.
Right.
Okay.
So you said it's observed minus expected, and the first chart was expected, right?
No.
The chart, the given
This
information.
is the actual. This chart is the actual.
The observed.
The observed.
The observed. Okay.
Expected is
What we
what's in
calculate.
16. Yeah.
Okay.
Is those proportions. 50% supporting, 15% opposing, and 35% neutral. So are the data statistically significant at the 5% significance level? So how many degrees of freedom do we have?
289.
to do R minus 1,
Oh,
C minus 1.
yeah.
There's no column.
There's no column, so close.
R minus 1.
So minus.
Just R minus 1.
So we have, actually it's C minus 1. There's no rows, right?
Oh, yeah.
C minus 1, which is.
Oh, so C. Wait, no rows. So just get rid of that. C minus 1 would be 2.
2, right? So we're going to use table F,
Okay, or do that.
not the F table. Those are different. Table F are chi-square values for chi-square distribution. F values are for ANOVA.
Way behind.
We're not there yet, so don't go there. And I think they're back to back in your book, so very easy to get it.
Table F.
Table F, not F critical values.
Okay. So it's between 0.005 and 0.0025.
Yeah, so we find that 0.0025 to 0.005. So what did we do? Reject the null, accept the null. Reject. P equals P is less than 0.05. So therefore the data are statistically significant at the 5% significance level.
So for chi-square, we don't have to like multiply P by 2 or anything like that.
No.
Oh, okay.
Sorry, because it's 2
Yeah.
Wait, can we
Because
just
when
walk-
we ask,
20.
because of the shape of the curve, it's skewed.
Right. Yeah. You can't. Okay. You're gonna give us all these tables, right?
Yes.
Oh.
Can we just walk through this chart again? So our degrees of freedom was 2, and then we get 10.98, so that's between here and here?
Yep.
Okay. And then, so, why am I blanking out on how to read this now?
So these are
so we're just
your
comparing it.
p-values,
Yeah.
right?
Yeah.
So it's somewhere
so,
between those p-values.
and it's less than this, so we
Yeah.
reject that off. Okay.
Do you know if we're getting the formulas again, or?
Yes. Yes.
Okay. Do you think that this is a good indication of the?
This is a great indication of what's going to be on your exam. Yes. So now we've moved on to ANOVA. We're moving on to ANOVA. How are we doing for time? It's 5 after 12.
Going faster than the last review session.
Okay. So use the following to answer questions 20 to 26. A service center for electronic equipment is conducting a study on 3 of their technicians, Joe, John, and James. All these specialize in repairing DVD players. All 3 specialize in repairing DVD players. The study was performed to assess the service time of fixing the DVD players. The manager of the service center wishes to assess the average service times for their 3 technicians are equal, whereas null hypothesis is that the mean of 1 equals the mean of 2 equals the mean of 3. So that means what? What does that mean? What are we saying by our null hypothesis?
All the service times are the same.
Between
The 3 technicians.
exactly. So the mean service time on a DVD player is the same between Joe, John, and James. So each technician, so what would be our alternative hypothesis?
That they're different? The times are different?
At least one is different from the other, right?
Mm-hmm.
At least one is not different than at least one other.
So could you have like multiple alternative hypotheses, or
You would
like
say
if you're writing
like
out
mu1 does not equal mu2, does not equal mu3.
Okay.
You really don't find out until you do a post hoc test, and I think we talked about the Bonferroni. Another popular one is Tukey's. When you do SPSS, you go to your package, you can select which post hoc test you want to do. By hand, it's painful. I would just do a t-test between 2 groups. I would just do 3 t-tests. Does that make sense?
Okay.
Okay. So how many DVD players were included in this study? So what we're given is, we're given descriptive statistics. We're given what we might get from a statistical package, right? So we put our data into a software package, and we're given descriptive statistics, and we're given an ANOVA table.
So 43.
45?
45. Why?
Because the degrees of freedom is 44, so
Right.
you just add 1.
So we're given that degrees of freedom is 44, and we get degrees of freedom by doing n minus 1. And in our ANOVA table, we see that our total degrees of freedom is 44, and so we have to add 1 to get our n.
So then why is it 42 within each group?
would
It's-
each group have its own?
Yeah, it would be minus. It'd still be subtracting group minus 1. So it'd be
I
subtracting
thought like
J and
if it
K.
said there was within the groups that meant each person had 43 and you subtracted 1. That's not right. No. Okay.
We go by
So you
total.
just do by the total. Okay.
What is the value of an estimate of the common standard deviation?
So you take the square root of 71.57?
And what do we get?
8.459.
B?
Any other opinions? Any other thoughts? So the estimate of the common standard deviation is going to be the square root of your mean square error. On this graph, on this chart, which one is your mean square error? Okay, but we have mean square, right? Which one is the mean square error?
74.86?
Yep. So we take the square root of that.
And that's
8.6.
because, and it's, why is it that and not 14?
And
Not
14.28.
14.28.
because between groups is what they have in common, and within groups is
Okay.
how they vary, and that's what we're looking for.
Okay.
Is variance.
So it's 8.65.
Mm-hmm.
And what was that value again? The 74.86?
And you don't add them?
Mean square
Mean
error.
square error.
You wouldn't add them.
But we're looking for how they vary. And isn't that varying between the groups?
Mm-hmm. Within the groups.
So we're looking within.
It's how they vary within.
Okay.
Okay, so under the null hypothesis of equality of population means, what is the point estimate of the common mean? So this is a more straightforward question.
65.88.
Yeah, 65.88.
Okay. So just in general, if it's asking, sorry, I'm so confused about 20. If it's ever asking how many are included, you just always do the degrees of
total?
freedom of the total, no matter what. Okay.
Because between groups is
How many groups there are
groups minus 1, and within groups
is something else.
it's something
Okay,
else.
that's fine. I just
Yeah.
understand.
So we're gonna just finish this section and then we can. Under the null hypothesis of equality of population means, what is